Hey guys, so last chapter, 8.1 today. Average value of a function and accumulation of rate functions. Okay, so first we're going to discover the formula for the average value of a function. The average value of a function represents its average height. So right now what we're going to do is we're going to draw a segment from A to B in the figure at the right, which could represent the average height of f of x on A to B. So average, of course, is between 2 points is halfway. So I'm going to try to do halfway. So right there. Okay, that looks good. Find the area of the rectangle form. Well, of course, we have height, and this is our height right here. But when we talk about our width, what is the value of this width right here? Well, if you can't see it right away, think of numbers, right? Let's say this is 2 and that is 5, right? Well, that would be the width is 3. So how can we represent that in terms of B and A? Well, that would be B minus A is our width, okay? Now here for 3, we have the integral of f of x equals B minus A times the height. And now we're going to solve for the height. Because don't forget area under the curve. And we're just going to do the area of the rectangle, sorry. Because the area under the curve should equal the area of the rectangle. Okay, so these two are equal. So if I were to solve for height here, we would have the integral from A to B of f of x dx divided by r b minus a. That equals our height. So I might go back here and put a little note so you have this in your notes, that the area of the rectangle is equal to the area under the curve. Let's see if you guys can picture that. Go back to that rectangle. Area under curve from here to here, we have this curve right here, right? But if we did halfway, don't those two equal? And now we have the area of the rectangle. So that is how the area of the rectangle is equal to the area under the curve. Okay. So let's talk about this formula. Average value of f of x on A to B equals f of c if, okay, the area of the region divided by the width of the region. And by the way, the width of the region is just a constant. And what do we usually do with constants? We pull it out front. Well, this would be 1 over b to the a. So lots of times, guys, I like memorizing this one better. Now, don't forget, all this that's going on, f of x must be continuous. So you might want to prove that first before you use the average value theorem. Okay. So here, find the average value of f of x equals x cubed minus x on the interval 0 to 2 without using the calculator. Right away, we can see that it's continuous. Check number 1. Now, average rate. So usually what they do, guys, to label this correctly is they do label it as f of average. So they know what you're doing. So I'm going to go 1 over, and it's b minus a, so 2 minus 0, times the integral from 0 to 2 of our f of x dx. So of x cubed minus x dx. And now we're going to take the integral. So I have 1/2 out front. And this is just a power rule. So x to the 4th over 4 minus x squared over 2. And we're going from 0 to 2. And now we're actually going to do that math. Okay, don't forget this 1/2 goes to both, so when you do your 0 and your 2. So upper boundary goes first, so 1/2 times 2 to the 4th is 16. So we have 16 over 4 minus 4 over 2. Okay, that's plugging in our upper boundary. And then we have minus, that 1/2 is still there, right? 0 over 4 minus 0 over 2. Do that calculation out, and we get the value of 1. So your area under the curve would be 1. Now what we're going to do is we're going to use our calculator to find the value of C, in which the interval of 0 to 2, where C is the average value found in example 4. So we're actually going to look at that average value. Okay, so in our calculator, the way we do that, right, is we have y1, y2. Looks like I need to charge my calculator today, guys. So y1, let me clear out everything else. We have, we want to equal to 1. So let me write this down because I have to write down everything that I'm doing for anyone to grade it, right? So I'm taking our function and I'm setting it equal to the average value to find out what C value would give us this average area of 1. Okay. So in our second equation here, we got x cubed minus x, graph it. Of course, that's the graph we see, right? But what we're going to do is, hold on, let me change the window. Let's go -1 to 3. No. -1 to 3. Okay, graph. Still don't like that. Why don't I like? Because of course I should be doing that on the y value. Sometimes I'm glad that we do this, guys, because then you can see that you have to think about what values you're maxing and mining. There we go. So much better, right? So what we're going to do now is see where it equals. Now we're going to the positive, right? Because this just comes down below. And plus we're only going from 0 to 2. So that helps. So second trace, intersect. Let's get close to that intersection. 1, 2, 3. So that means x equals 1.325 because we're rounding to the third decimal place. And that's what the value of C or x would give us this average value. All right, let's look at our accumulation of our rate function. So in lesson 4.1, you interpreted the rate function models. We can now revisit the topic and include the concept of accumulation. So what that means is, guys, when we go and we take the integral of a rate function, we are finding the total amount produced. Okay, so accumulation, total. And that is the words you are going to use when writing your sentences for accumulation, okay? So the graph at the right models the rate of rainfall in inches per hour from midnight to 6 a.m. during a tropical storm. So let's remember the y value here is a rate. So what we're going to do is we're going to write complete sentences to explain what point A is on the graph, but we're also going to write sentences for 8, 10, and 12, okay? So write a complete sentence to explain what point A is on the graph. Include numbers and units. Okay, well, point A is saying that at 3 a.m. 3 a.m. We're talking about the situation of rainfall is falling at the rate of 1 inch per hour. So of course, in here, guys, I'm just saying this is the coordinate pair 3, 1. What does the 3 represent? What does 1 represent according to the situation? All right, number 7. What is the slope of the graph at point B and point C? Okay, so point B and point C. Oh, between. There we go. I forgot a word, right? So what is this? Well, we go over to the right one and we go down 1. I know you want to count spots, but count units. So that means the slope, which we represent as m, equals -1 inch per hour. And be careful because this is a rate within itself. So per hour, because we're going, our y value is inch per hour, and we're going across an hour. Okay, now let's write a complete sentence explaining what that means. And what that means, don't forget, if we're looking at from B to C, we're looking from 4 to 5. Well, what does 4 to 5 represent? So between 4 and 5 a.m. I might want to say 4 a.m. and 5 a.m. The rate of rainfall is, now this is where, because we're talking about rate, we can talk about increasing, decreasing, right? So, or slope, we talk about increasing, decreasing. Negative means decreasing. At a rate of 1 inch per hour per hour. All right, number 9, find the integral from 3 to 5. Well, integral is area under the curve. So if you look from 3 to 5, we have a trapezoid. How do we find the area of a trapezoid? Well, that's 1/2 the height in this case. So the height here is 1 times base 1. So if we look, base 1 right here is 1 plus base 2. We're going to 3 to 5. So that is 2. So we get 3.5, 3/2 inches. Okay, write a complete sentence to explain the meaning. Now, because we found the integral, we're going backwards. That's where we find the total. So from our rate graph, when we go backwards with integration, we're finding the total. So I would say that between, sorry guys, my handwriting is icky today. Between, we're looking at 3 a.m. to 5 a.m. it rained. So you always got to go back to the situation. A total of 3/2 inches. Okay. Number 11, approximate. Okay, means we don't have to find the exact, between 0 and 6. And now the reason why we also have to approximate is because we can't divide this into nice things, right? Or nice shapes. So you know what? I'm going to draw a triangle. Okay. So, and let's see what we have. First of all, let's do that triangle. So we have 1/2. The base of that triangle is 3. The height of that triangle is 1. And then we also have to add on that trapezoid, which we found earlier as 3/2. All right, when we do this math out, we end up getting, let's see, that would be 6/2, which is 3. Now we're going to write a complete sentence to explain the meaning of number 11. Okay, so here we would say between, not as much as you want to put 0 down. What does 0 represent? 0 represents midnight, right? Between midnight and 6 a.m. approximately, not the exact total. So let's remind ourselves that it's approximately 3 it rained. Usually you don't want to use approximately. I have to talk about raining, right? Between midnight and 6 a.m. approximately it rained a total of 3 inches. Awesome. So we have 2 things to go over that are brand new. So let's do some practice and see where we need to reevaluate.